Electronic resistor color codes explaining for 4 or 5 bands. Resistors are one of the most common components in electronic circuits. They limit the flow of the electric current and are identified by a series of color bands painted on their body. The color code is a standardized system that allows us to know the resistance value without writing numbers on the small surface on the component. In a resistor with 4 bands, the first 2 colors represent the first 2 digits of the resistance value. The third band indicates the multiplier, and the fourth band shows the tolerance, which is possible error range. In case of 5 bands resistor, the first 3 colors represent the digit, the 4 is the multiplier, and the 5 is the tolerance. For example, if a resistor has the color brown, black, red, and gold, it means 10 multiplied by 100, which is 1000 ohms, with a tolerance of plus or minus 5%. The gold and silver color are usually used to show tolerance, while the color from black to white represent digits from 0 to 9. Understanding this color code is very important for everyone working with electronics, because reading values quickly allow you to build circuits correctly. The system avoids mistakes that makes resistor universal around the world. By practicing, you can memorize the color code order: black, brown, red, orange, yellow, green, blue, violet, gray, and white. This is the way you can calculate resistance value almost instantly. Energy of a capacitor. Circuit physics academic. A capacitor is an electrical component that stores energy in the form of an electric field. It consists of 2 conductive planes separated by an insulator of the electric material. When a voltage source is connected, charge accumulates on the planes, and the capacitor stores electrical energy. The energy stored in a capacitor is important in many applications for electronic circuits to power system. The formula for the energy of a capacitor is 1/2 multiplied by the capacitance, that the square of the voltage. This means that the amount of stored energy depends on both the capacitance value, which is measured in farads, and the applied voltage. The higher the capacitance or voltage, the more energy the capacitor can hold. The Khan academic video explained that the derivation of this formula comes from integrating the work done to move shapes onto the capacitor plates. At first, it takes a little energy to move the first charges, but as more changes accumulate, it becomes harder to push additional charges because of the electrical repulsion. This is why the energy depends on the square of the voltage. Capacitor plays the key role is smoothing voltage, storing energy temporarily, and providing power in short bursts. For example, they are using camera flashes, radios, circuits, and power conditional devices. Understanding how capacitors store energy helps us design circuits and are safe and efficient.